Following example, we're asked to find the derivative of y equals 3 outside of 4 minus sine inverse of 2x, all cubed. We're going to have to apply the chain rule for this one. Chain rule says start from the outside and work our way in. So the 3 comes down first. 3 by 3 is 9. Bracket stays the same. And the exponent becomes a 2. And we're going to multiply that by the derivative of the part that didn't change. And this time I'm going to write that a little different. Instead of doing the derivative right away, I'm actually going to say the inside part derives, or prime. So we're going to take this derivative. And we can do this if we want to kind of remind ourselves that each step we're only going to do one thing. So first we did the exponent. We're going to leave this the same and take its derivative. So that tells us that in the next line we're going to keep the first now is done. And we're taking this derivative. So this derivative, 4 is 0, minus the derivative of sine is 1 over root 1 minus 2x all squared, multiplied by, and I'm going to use that notation again and write the 2x prime, so the derivative of that part that didn't change. So again, here we are working with one part. We did the derivative of the 4 and the derivative of the sine part, but we're just writing and the derivative of this part. So when we see that prime, that's telling us we need to take that derivative. Now if you're finding this notation difficult to follow, don't worry, it's not necessary. It's just giving you a second way to kind of look at these questions. Some students really struggle with keeping what steps to do in order, so sometimes by using this notation we can keep track of our work a little better. So here we need to take this derivative. So the derivative of 2x is 2, so we can put that up top. The bottom stays the same. So hopefully you recognize in each step one part has changed. And that's kind of the only real use to using this notation. Otherwise, if you're comfortable doing this, you could probably write this whole line all at once, or even this whole line all at once, and not have to worry about using this way. But certainly something to consider if you are struggling. The next example, inverse tan of 1 minus t over 1 plus t. The derivative then, start with the tan inverse. And this one we'll do without any special notation. So the derivative of tan inverse is 1 over 1 plus 1 minus t over 1 plus t all squared, multiplied by the derivative of that part, the argument. That's a quotient, so this is a quotient rule. So quotient rule, derivative of the top minus 1. Keep the bottom. Minus derivative of the bottom. So that's 1. Keep the top. Minus t all over the bottom, or denominator, squared. So there's the derivative. Now it's all down to the algebra. Negative 1 minus 1 gives negative 2. We're just looking at this now. Let's leave this first part since it's a bit of a mess. Hopefully some things will cancel there momentarily. So over here we're going to get minus 2. Minus t minus minus is plus, so minus t plus t actually cancels. So the top is just minus 2. And the denominator stays the same. So that's a little neater. Typically I would give you full marks for this because again I'm focusing on the calculus. You've got the calculus part right if you can get to here. The rest is just algebra. This one does continue to simplify a significant amount though. If you multiply these fractions, negative 2 up top, 1 plus t squared gets multiplied with the 1, it also gets multiplied with this term, which actually cancels, and you're left with 1 minus t all squared. And even that will continue to simplify. If you expand the brackets, you get 1 plus 2t plus t squared. And over here you get 1 minus 2t plus t squared, which you can work out if you want and show that the final answer for the denominator will be 2 plus 2t squared. Removing the common factor of 2 then can give us our fully simplified answer of minus 1 over 1 plus t squared. Now, here's the important part. Make sure you can get the calculus part. Great if you can get to this. If not, the minor simplifications are all that are really necessary.